In part two, we're going to be talking about developing Playbook components. And if you are very interested in this, we'll actually hold a section in the next hour to do this in a much more hands-on way. But here we'll give you a taste of that. So developing Playbook components involves this prototyping interface. And to really understand how to develop them, you need to better understand how the Playbook components work together. So there's these different types of components. You have what's called a prompt. So this is a component that may or may not take user input, but will produce some data type. For instance, gene input will produce a string that is representing a gene. So this gene is its own type, referring to a gene symbol, and the gene input is its own component, which handles this input form. Once you have this gene type, this could be an input to the next component. So one example next component would be, for instance, the GTEx expression API, which is going to contact a REST API and give this gene that was inputted as an argument. And then the results of that API will be a JSON document, which we will format into another standardized data type, in this case, ranked tissue. So we may have multiple components that fit in this slot. They take the same type of input, a gene, and may produce the same type of output, this ranked tissue type. And so what we are doing when we're coding new components is registering each of these types and referring to them if you reuse them. Once you have, say, this ranked tissue, it's working in isolation to visualize this like table of the tissues on the left and the actual rankings or the scores on the right. And this can then be used as input for another metanode or another component rather. And so that other component, for instance, might be construct a bar plot. So constructing a bar plot, again, will take this ranked tissue data type, will then render it with some visualization library, and then it will produce that rendering. So these intermediary things that don't take user input per se, they take some existing type and produce some new type. We're calling resolvers. And then these end data types, we're calling views because we'll have some rendering layer with them. So what I've decided to do is just give you a hands-on view of developing a component. And so for that, let me open my editor. And so this is the Playbook workflow. This is the PWB Playbook Workflow Builder project. So to get this, we will clone it off of GitHub. Again, I will show this more later. But once you've cloned it and opened it up, it looks like this. And what we need to do is actually run it. And once we run with npm run dev, we will get a server that we can load up locally. So to that one question, can you run this outside of the playbook? Yes, you can. If you clone the repository and you install all relevant dependencies, you can run it like this, and now we can access it locally. And this, if I would go to the graph mode, will work the same way the public site works. Um, so once that finishes, yeah. So again, we can do the same thing we can there, but what we have for developers is this prototyping interface. So the prototyping interface looks something like this, and close these. Basically, it's a similar type of interface as before, but these, when you put in something, first of all, you can interact with the prompts over here, and then the actual input that is being used to render shows up on the right. And if we're going to execute any meta node, the left is showing the rendering, and the right is showing the data that goes into that rendering. So we can really manipulate this to see like how it will change things. Um, but that's kind of how this interface works. And what I want to do is we have a gene count matrix um, that we made before. So let's sign in as this developer user, go to upload a gene count matrix. When we do this, you can see that this is what that matrix looks like internally. Um, and then one thing that we did was manually label the samples. We can do that again here. And we have lima voom as one way to perform differential expression. But we recently received an issue that wants to put a different form of differential expression. We also have a characteristic direction. So let's add a new one, and we're going to just add t-test, students t-test as a simple example of having a new type of differential expression. So to do that, from here, what we'll do is what I've done is prepared these. So these would be the changes I would do. So what I've done is I copied the lima voom component, which is already there, over to this new folder t-test. That's all that was done. So, but now what we want to do is modify this so that it now does a t-test. So to do that, what we're going to do is we're going to modify the names. So instead of whom, now we'll just have t-test. We can change the description as well to be a t-test instead of whom. And it turns out that this package that we use to do voom also has t-test in it. So this change becomes somewhat easy. We can change all the identifiers. So we can see that this is what a meta node, how it's registered. It has the label over here. It has a description. It has what goes in, which imports from this previous format. And it has what comes out, which goes to this other format. And another neat thing is these types are well annotated using TypeScript. So if I do props dot, we can see we have inputs and data, and all of the types that are there are type checked properly. So if we would actually put in something that is incompatible, the editor would show that it is not allowed, like it's not specified properly. Um, but so this is how we would modify the main meta node. And the way this component is working is that it is calling this Python module. So that Python module is defined here. It calls this one function, which will load the and data file, perform the differential expression analysis, and then upload the new file that has been produced. The final thing we need to do is actually change the name here. So instead of limavoom, we have t-test, we have our new author. And once we've done this, we need to run this command npm run codegen components. And what that will do is register the component automatically. And once we do that, the interface already updated with the t-test now available here. So if we would click this, what we'll find out is actually there's an error. So this is like how you are developing these components. So it turns out that this change is not exactly compatible because the t-test is returning a different set of columns than the other one. So it's expecting this log full change, but we actually are just performing the t-test and returning a statistic. So we can fix this up. So in the next step, this one, actually, what we need to do is actually import log fold change also. And then what we'll do is instead of renaming these, it turns out t-test is returning p-val, it's returning adjusted p-val, and then with log full change, it returns log fc. So this is actually set up to be in the same format that the old one outputted. So if we come here and you can see that, by the way, from limavoom. So I can actually, from here, I can run limavoom as well. So we can see what that one used to look like. But you can also see here. See, so limavoom, it has the statistic, it has p-val, adjusted p-val, and log full change. Now, if we do this t-test, given these new changes, instead of an error, we now have our log full change over here. And because this example data frame has very little variance, we actually have a lot of extremely significant upregulated and downregulated gene sets. And this is partially why we don't use t-tests typically, because we don't really have enough samples to get what we need. But nonetheless, this will still work. And so now we have this a new method for performing differential expression. And again, from here, we can still get scored genes, and we can still interact with it the same way we could interact with the output of the limavoom. So we could perform that same exact workflow we had before, but now we're doing a t-test instead. So this is how we are developing these components. And another thing that you'll want to do is also to test it on the main platform. So if we go to the graph mode, we can, again, go through the same process. We put in our notebook, our count matrix, we manually label the samples. And from here, we can get the t-test that we created. So you can see now that all we had to do is actually register um, essentially the few files in here, and now it is available as part of this platform. And it will show up whenever you have the input that goes into it, and it will be executable. So yeah, again, we can still do the same thing from here. And if we view the report, we have our t-test in here, and we could expand from here, do Lima Voom, and then we could even compare these. So let's do that. So if I just take the top genes, top 10, and then here I take the top 10 as well. Um, top, actually, I better do more because, okay, top 100. We can actually now get sets. Set. And with sets, we can actually compare the sets. So I think yeah, assemble a GMT. So when we do this, we have the set from one side and we have the set from the other side. And with GMT, we can compare the sets. Um, and actually, we need to name them. So let's name it A and B. And they're actually completely not non-overlapping sets. But this is how we would start to use this new data file. So with that, I think I will start wrapping up. So I'll go back here. So first, I'd like to acknowledge the Playbook partnership team, these different programs that contributed to this platform and helped build it from the ground up. The Common Fund data ecosystem, which has, other programs have their APIs represented here, and their hard work is what made this type of platform possible. And of course, the NIH for their uh, support throughout the project, both with feedback and financially.